Alright. How's everyone doing? Cool. So, I'm going to be talking about robots and Go. Has anyone done any robotics, or IoT before? Cool. Alright. So, just a little bit about myself. Thejana Sakunajith, but you can just call me TJ. Work at SM1, which is right on Bridge Road. So we're a construction SaaS platform, if anyone's interested. So, and we are in fact hiring. Okay, let's look at a small video. Just a bit of background about this video. I'm a recent graduate from RMIT University Computer Science Department, and as our capstone project, we got to work with a research robot called Baxter from Rethink Robotics, and we got to present it at Unite Melbourne, which is the Unity gaming game developers conference, and OSGP as well this year. So this is something that the RMIT gaming department compiled. So cancel. Audio.
My name is Stefan Kreuter. I'm the director for the Center for Game Design Research at RMIT University, and this project is a collaboration between the Center for Game Design Research and the VX Lab led by Professor Heinz Schmidt and students from the School of Science that were supervised by Professor James Harland. This project is about virtual reality and robotics. When people have a virtual reality experience, they are transported to a virtual world using head-mounted display and headphones. In such a virtual world, they can observe, walk around, and interact with objects. But when people interact with objects in the virtual world, they cannot feel them in the same way they can feel objects in the real world. This project examines how robotics can be used to provide the missing haptic feedback in virtual reality experiences. To test this, we have developed an interface that allows us to control the industrial robot Baxter from within the game engine Unity that generates the virtual reality experience. In this example, users can play a virtual sword fighting game against a virtual opponent, and unlike other virtual reality experiences, feel when the swords cross, which is a tremendously exciting and satisfying experience. And we're just at the beginning to explore the possibilities for games, entertainment, but also a range of other applications in skills training and Industry 4.0 applications.
My part of the VR project is to do the virtuality part. I'm using the Unity game engine to develop the game's logic. From the game side, I would create the game mechanics, such as the robot shooting at you, or how the calculations for virtuality swords is towards the robot.
Things that contributed in this project was the development of the robot to interface with Unity itself.
I was in charge of the robotics component of the project, where I got to design the architecture inside the robot that speaks to the VR experience.
For this project, I came in at the sort of last minute to help polish the code and get it up to production grade, so things would be reliable at the conference.
All right. So this robot actually doesn't run Gobot. It's based off of a meta operating system called ROS, which stands for Robotic Operating System. So to talk a little bit about the architecture that's in that project, obviously you have Unity VR that sends a WebSocket, sends messages across from using a WebSocket connection, and we intercept that message in a proxy server kind of thing and converts it into a format that ROS understands, because they've got their own custom formats, message formats that you have to compile messages with, and then we give it to a Baxter VR action server, which basically triggers random actions, which are different movements from the robot side towards the opponent, and we actually detect the collisions from Unity VR, and we send messages across to messages across when we want to stop a particular movement and start it from scratch, because we don't want to finish a movement if the two swords hit each other. So after that, we've got a whole lot of infrastructure that ROS provides and Baxter's developers provide, which basically solve inverse kinematics, which is the amount that the different parts of the arm has to move to bring the wrist, bring the tip of the hand to a certain position in 3D space. And there are two main featurely supported client libraries for ROS, which are written in C++ and Python. And there are some other client libraries too. There's one for Go called ROS Go, which isn't quite complete and isn't maintained anymore. So I am working on one, but I haven't completed it yet. But obviously, contributions welcome. I have the link to it in the slides if you want. So, basics of robotics. You have input, processing, output as a usual computer. Only we call them sensors and actuators and controllers. That's basics. Okay, some physics stuff that I wish I knew before I started working on the project were the whole inverse kinematics thing, which I had to go and learn about to understand how movement worked. There are packages for ROS that do this for you, but when you actually try and use them to plan parts, they can be a little tricky to get it to work naturally. It might try and twist the arm in a way that wouldn't be natural, basically. And there's a new thing that I learned called the quaternion. If anyone's heard of it, it basically encodes the positioning, XYZ positioning, and somehow a rotation as well. I'm not really across it yet, but I know how to use it in ROS at least. So those are the two physics things I learned while doing the project. Just a little intro to ROS. Before I get into Gobot, I wanted to talk about how production grade robotics framework works. Gobot is well and good, but I don't really think it's ready to be used in robots yet. So just a little background about ROS. It's not an OS. It's more of a middleware layer, and it runs on Debian Linux distributions, and it's supported on AMD64 and ARM. Started in 2007 at Stanford, and is part of a organization called Open Source Robotics Foundation. Basically has helpful libraries called packages, just like in Go, and it's used in a lot of real-world applications and even competitions. RMIT does quite a bit of ROS work. They even have a fleet of drones that are running on ROS. So the core components of ROS are basically a message passing architecture, a RPC-based server infrastructure, and a node graph and a distributed parameter server are the four main components of ROS. So talking a little bit about the pub/sub infrastructure, it is asynchronous and uses something called ROS topics. And there's in the computation graph, there's a master node that holds a topic register and a node register that basically provides the registered and deregistered and sort of controls the whole pub/sub infrastructure that ROS uses. And it uses a custom message format over a TCP, which you should define when you're creating a package in ROS. And the whole RPC, talking about RPC, it's based off of XML RPC, which is not quite my favorite encoding format, but that's what it is. And so the whole computation and control of ROS is based off of a node graph, which is kind of similar to a distributed microservices kind of environment. The ROS topics are just like a Unix file system with / at the top layer, and you have different namespaces, and you have local and global namespaces that you can access using topics. And you obviously have key values, so a distributed parameter server if you want to set up configs and different kind of things. And ROS has two types of custom types: message types and service types. Service types are basically interfaces to the ROS services that we talked about, and message types are different messages that pass around in the pub/sub infrastructure. Packages have manifests called package.xml, which you have to define every bit of everything in ROS. Like you have build dependencies, some like runtime dependencies, and everything else. And there's an interesting format called URDF, which is Universal Robotics Definition Language or something, definition format, I guess, which is used to define what a robot is, what the different physics associated with a robot looks like, and using that you can use a tool called Gazebo to generate a 3D model just by using that URDF format that comes built in with any ROS distribution that you download. Okay, story about Gobot. That's the whole ROS side of things. That's what universities and companies use to build robots right now. So Gobot is something that came out of the people who built the BB-8 robot. If you've seen that, it's from a company called Sphere, and the person who actually started this project, his team actually built the drivers for BB-8, and he used that knowledge to build a framework for robotics in Go. And this is not just a robotics framework. It can also be used for IoT applications as well. And it has a pretty nice interface that is based off the peripheral I/O package, experimental peripheral I/O package that Go has, and it's based off of sysfs, which is the Unix files for different ports and stuff like that. If you remember from Unix 101, so it is extensible. It has different things called platforms and drivers and adapters and stuff like that. They can write packages to support different hardware devices. And it comes built in, and the community has developed quite a bit of packages that support general pieces of hardware that you can find, like Raspberry Pis, like AR drones and stuff like that. So you've got a lot of examples on their website there. Moving on, Gobot platforms. So there's no definition for a platform. I tried looking for it. There's no definition for a platform, and lately there's been some overlap between platform and driver, and there's a blurred line between what a platform is and what a driver is. So anything you see here could be a platform. So you've got Intel Edisons, you've got Leap Motions, joysticks, AR drones, quadcopters, and Raspberry Pis, and BeagleBones, even that thing, I don't know what it's called. They've got plenty of different platforms that they support. But the documentation for all these platforms aren't very complete, but if you go to Godoc and look up the Go package URL that you have, you can find documentation on Godoc. So the way that you work with Gobot is you import the core of Gobot using gobot.io/x/gobot, and it brings in all the abstractions that Gobot provides, which is what a robot is, and different structures and interfaces that they've sort of compiled to make sure, sort of like a standard on which different package vendors should develop their packages. And you have, if you're after a certain platform, you go this URL / whatever package platform that you're using. So in this case, I've used Raspberry Pi's platform, and then so this is the core of Gobot that I talked about. So you have something called a robot, which takes in a slice of connections, a slice of Gobot adapter structures and driver structures to to compose a robot structure. So you can like depending on the hardware that you use, and depending on whether you want one robot or a swarm of robots, you can mix and match and create like your definition of what the robot is using this robot structure. And you have definitely obviously you have adapters which basically link to a platforms package, and driver structures that links to a drivers package. And this is how you install drivers. So let's look at a couple of packages and programs that I've written. So,
can you zoom in a bit?
Oh, sure. Sorry. Okay. So you can say I'm more of a dev person than a go-get person. So, right. Okay. This is basically your hello world of Raspberry Pi, IoT, or anything related to hardware, I guess, which is blinking light. Right. So I've imported Gobot's Raspberry Pi platform and GPIO driver. So like a driver can be any interface, hardware interface. We've got I2C, SPI, PWM, GPIO, which stands for General Purpose I/O, which is basically on or off. You can read and write on, state on or off, and different there are analog interfaces such as AIO, which are used in different hardware devices and do different things. And got obviously Gobot, and creating a new adapter from Raspberry Pi, new driver for GPIO that uses this adapter and pin number 7 of the Raspberry Pi, which is connected to an LED in a breadboard somewhere. And then we define what the work looks like for the robot. So like the robot gets a function called work that basically the robot does. In this case, every second it toggles the signal that goes out to the LED, which turns them on and off every second. And then you create the robot structure, name them something, give them slice of connections. In this case, it is the adapter that we created, and slice of devices with a driver. You tell it what to do. You just go robot.start, and it does it until you control C out of it. But in this case, since it's a Raspberry Pi and it's a Unix machine, the way that you deploy this is you SCP the binary that you get by running this Go build, with obviously using ARM or cross-current compiling to ARM version 6 on Linux. You SCP onto the Raspberry Pi that you have and SSH in and run the thing, basically. Yep, so that's Raspberry Pi. I've got one more. I'll come back to it. Okay, so Gobot comes in 3 flavors. So like, as I said, Gobot isn't really a robotics thing. So like, you can create programs in Gobot using the classic Gobot flavor, which we just saw. You give it a driver, you give it a connection, you tell it what to do, and it goes and does it. And then you got Metal Robot, which basically means that when you're creating a platform package, you can take more control over what classic more than what classic Gobot gives you, and you can actually prescribe what your platform wants to do in Gobot. And then you've got Master Gobot, basically a master slave pattern. Gobot in this case works as a API, and you can actually there's another structure called gobot.command that you can use in like HTTP handlers or something, and you can actually hook up a IoT or a robotics application to a API server and control it like that. So in this case, Master Gobot acts as a master, and it gets a swarm of robots that does something when it tells them to do something. That's the next thing that I have, SwarmBot. So this is based on Sphero's original bot. Like, it's like BB8 but not quite. It's called Sphero, and it's a SwarmBot. Right. Starting from main. So Sphero connects through Bluetooth Low Energy. As you can see there, RF connections, and Gobot acts as a master to a range of spheres, and you add the robot to the swarm, and you basically start the master like you would in any other situation. And the SwarmBot thing, right? So it imports the Sphero platform, creates an adapter, creates a driver. In this case, this Sphero is a metal Gobot, so it actually has all the things that it needs to operate without using Gobot's core APIs, and you give it the function. In this case, if it detects a collision which uses Gobot's eventer interface, and if it detects a collision, it says collision detected, and every second it rolls in speed 100 and this direction. And it has a small set of LEDs that glow in the little sphere-like thing. And yeah, you just alternate between a few RGB combinations every 3 seconds there. And basically you create everything and create a robot, you add it to the master's robot swarm. And when you run the master, it runs all the robots as well. So that's how you create a swarm of robots. Okay, let's get back to the presentation. Right. Okay, so I don't think this is enough for the Go community, because the Go community has built a lot of bots. So Go does have some experimental support for peripheral I/O, as I said before. They've got, if you go to golang.org/pkg, right underneath the list there, you can see experimental, and then there's /IO/SPI and I2C, which are those drivers that I talked about. I2C stands for inter-integrated circuits, and SPI, can't remember what it stands for, but like it's basically the same as I2C. Both are basically serial interfaces that I2C uses 2 wires, but SPI uses 1. That's the only difference, actually. So there are more packages that the community has built to control hardware, but they're basically used they are based off of Unix's abstractions, because like Go doesn't have really Go needs a runtime to run, and it needs an operating system, so like it's not ROS. So yeah, this is actually the ROS Go package that I talked about, which hasn't been updated in like 2 years, and it only really has support for the pubs up infrastructure of ROS, nothing else. So what I am working on, I'm working on a ROS 2 client library. ROS is kind of old news right now. They're building it from scratch and calling it ROS Core, based off of the official C library. It's going to be the wrapper. It's going to be like, yeah, it's really fun using CGO. If anyone's used CGO before, they'll know. Why I'm like the reason why I'm using RCL is because they basically tell you that that's the preferred method of building plant libraries for ROS2, because they want to be able to change things without having to worry about all the different plant libraries that the community has built. So it's right up there. Contributions welcome, as always. I'm planning some ROS/Gobot workshops for RMIT computer science students, and doing some robotics work with Rust too, possibly developing another client library in Rust for ROS. That's quite a mouthful. Yep, that's it from me. The slides are up there, and if you're curious about the VX Lab of RMIT, you can go to that link and find more about VX Lab. Has a lot of technology that RMIT students get access to, and that's it from me. Thank you, everyone.
In your Sphero code, why do you stop the driver before continuing on with the rest of the work?
Sorry.
So you call Sphero driver.stop first.
Oh,
Why do you
that's
do that?
yeah. Sorry, that's something that I left out. Sorry. Yeah, it's my bad.
No further questions.
Okay.
So I see this is sorry, words. I see this is designed to run, say, with set from Raspberry Pi or Arduino or Stereo or others. What if you were to communicate with, say, something abstract over USB? Do you know if there are drivers for that?
There are Bluetooth low energy drivers. I'm not sure if there are USB drives, but there should be something that's related to Gobot, like even if it's not like indexed on their website, should be able to find a driver somewhere.
Parent.io has a bunch of Gobot compatible drivers with USB drives.
Cool.
Yeah.
Yeah, and I think there's also a JTAG plugin, so you can basically plug into most electronic devices
Yeah.
without doing anything crazy.
There's actually a talk on YouTube. If you search robots plus Go, that guy actually shows a lot about communicating with like general, like it was probably before Gobot, and he actually shows code to communicate directly with I2C and stuff like that, like with Raspberry Pis using the experimental I/O packages, like peripheral I/O packages. So if you want to check that out. Yeah.
Does Gobot have any support for like programmable runtime units, like you'll find on BeagleBone or?
I haven't actually looked at Gobot for BeagleBone yet. I'm actually planning on getting one. But yeah, there's a pretty good package for BeagleBone, and they say they support, like their website says they support BeagleBone, so you should be able to find something.
Thanks very much.
Yeah.